h of x models the path of a projectile. X is the horizontal distance from the firing point. Part A. At what distance from the starting point does the projectile reach its max height? Notice that h is a quadratic. If we graphed it, it's opening down, and it has a max. To find the vertex, the maximum of that quadratic, we use x equals negative b over 2 times a. In this case, b is 1. Then we have 2 times a. A is the fraction negative 32 over 10,000. Simplifying this, we get 156.25. To find the max height, we evaluate the function h at 156.25. That is negative 32 divided by 10,000 times 156.25 squared plus 156.25. This gives us 78.125. And part C, at what horizontal distance will the projectile strike the ground? Here we want the height h to be 0. That's when it strikes the ground. So we'll just set the function equal to 0. So we have negative 32 over 10,000 x squared plus x. And our goal here is to solve this quadratic. Since this is not easily factorable, probably the easiest way is to use the quadratic formula. Negative b plus or minus the square root of b squared minus 4 times a c all over 2 times a. Notice that this piece is just going to go away to 0. So we have negative 1 plus or minus the square root of 1, which is 1, all over 2 times negative 32 over 10,000. So we have two options here. We can use the negative 1 plus 1 or negative 1 minus 1. Negative 1 plus 1 in the numerator will give us 0. We don't want that one because 0 means that it's starting on the ground. We want to know when it strikes the ground. So we're going to be using the negative 1 minus 1 over 2 times negative 32 over 10,000. And this gives us 312.5. This is where the projectile strikes the ground.